I am the Philosophical Bachelor, and today I want to sum up Sanders Peirce's series of 5 articles on his Metaphysics, which was written over 2 years from 1891 to 1893 and published in philosophical journal The Monist. His metaphysics is systematic, governed by 2 key principles: chance, which he calls tyhcism, and continuity, which he calls synechism. It is a process metaphysics where broad development is an evolution of growth as opposed to mechanical cause and effect. Over the last few weeks, I have gone over each of his papers to try to draw out his main ideas. While there is a thread that links the articles, the series is best understood as a whole. I think we can benefit from a summing up, drawing the key ideas out more clearly and showing how they link with one another. Peirce is a polymath who has contributed to our knowledge in mathematics, logic, language, science, and statistics, though he is best known as the founder of the philosophical movement of pragmatism. In contrast to those fields, his metaphysics, however, has been widely ignored, with some of his commentators considering it a puzzling embarrassment. However, I find his metaphysics compelling because it is precisely puzzling and surprising, and yet seemingly spot on. He developed it in his 40s after substantial work in some of the other fields, and throughout the Monist papers, draw on ideas in science, mathematics, and logic. He begins the series with his take on epistemology, which we can consider as a meta-philosophy. He observes that in the history of philosophy, often some accidental happy thoughts of a thinker, suitable in isolation, is stretched too far to make it a complete metaphysical system. Then reformers try to patch up its failings, but that is insufficient since the patchwork does not sufficiently remedy the insufficiencies of the theories, and the new parts are not brought into sufficient harmony with the old good parts. Hence he thinks that the first appropriate step in philosophical system building involves an expansive study of prior theories to understand what works and what does not, what ideas are valuable to be retained, and what are not and to be discarded. Then a phase of thinking and planning is required, all before theory construction proper can begin. He walks the talk, which is why many of the 5 articles begin with a historical overview, after which it becomes clearer the need for his innovation. Peirce explains how theories negatively affect our understanding of reality. Take for instance how fundamental straight lines are in our understanding. But how did it become that way? Isaac Newton's first law of motion tells us that an object remains at rest or in uniform motion in a straight line, unless acted upon by external forces. This is not something that came from observation, since as we and Aristotle observe, objects slow down to a stop after a while. A ball rolling on the ground may make a turn. From William of Ockham, we also have the notion implanted in our minds that simplicity makes for the best theories. Peirce believes the reason why objects are postulated to travel in straight lines is due to how Euclidean geometry discusses straight lines as fundamental, hence giving us the impression that straight lines are the simplest curve, when in fact no curve is any more simple than any other curve. So when it came the time to figure out how light travels, the straight line is a good guess, though we now know that light need not always travel in straight lines from Albert Einstein's theory of relativity, which came 14 years after Peirce's first Monist paper. Besides, there is no logical reason to think that reality ought to behave in simple ways. From the success of our scientific theories, we have also come to believe that the laws of nature are immutable and inviolable. Every time you drop a rock, it always falls to the ground. It has never floated up. You recognize the law of gravity, a law of nature in action. Other laws help us build machines that work in a consistent way, all based on the laws of science. So Peirce's allegation that the laws are in fact not so certain comes as a surprise. He gives a simple example. When we measure something as simple as the length of a line drawn on a piece of paper, we do not get the same results on each measurement. Even with better instruments and scale, there is always a variance in each result. This is conventionally attributed to errors of observation, but Peirce is suggesting that the nature of reality is not so precise but somewhat fuzzy. We know today that the position of an electron in an atom cannot be precisely determined, though we can statistically estimate its position. Other examples used today to belabor the statistical nature of laws of nature include the half-life of a radioactive substance, or examples from quantum mechanics. Quantum mechanics has not yet been discovered in Peirce's time, but he points to yet other examples such as the laws governing viscosity and the kinetic theory of gases, which are laws of large numbers or statistical laws describing not the path of the individual molecules but the aggregate expectation we can get from the behavior of large number of particles. Beyond these specific laws, Peirce believes that all laws of nature are statistical, more a statement of what is probable than an absolute truth. Philosophers such as Spinoza have tried to aid the supposed precision and inviolability of science and mathematics, with the aim of setting up a metaphysical and ethical system that cannot be refuted. Spinoza's ethics begins with definitions and axioms, and from there develop a metaphysical and an ethical system. It is called the geometric method, named after how Euclid had laid out an irrefutable and logically tight proof of geometric theorems in his book, Elements. The method and Euclid's geometry was successful, with its axioms accepted for over 2,000 years, until the fifth axiom on parallel lines was demonstrated to be untrue around the 1830s. If even what was regarded as fundamental, unquestionable, and true, such as Euclidean axioms, can be shown to be false, how much more so for other theories? Peirce hence thinks that the time has come where what is accepted and thought incontrovertible, such as axioms, need to be questioned. In the early stages of scientific development, such questioning could only lead to confusion, but we have reached a stage where we, or rather Peirce, has an idea of how such assumptions and presuppositions can be corrected. His guiding idea is chance, which he terms tyhcism. In the beginning of time of the universe, there was only chance governing events. However, even chance occurrences can lead to a bias. For instance, a random series of coin tosses can result in streaks of heads or tails. From a bias comes the formation of habit. A coin tossed many times may get dinged by chance, making it more likely to come up heads. Heads then becomes the habit. If the bias becomes increasingly entrenched with the subsequent tosses, the way a small weakness becomes the site of increasing weakness and then failure in fracture mechanics, or simply how a stitch in time may save 9, the coin being increasingly dinged on one side may always come up heads, making the habit into a law. This coin always comes up heads. As one can see from this example of the coin, chance can lead to strict laws. Peirce thinks the laws of nature, which today seem strict, were earlier built on less strict rules until we get to the beginning where there was only chance. When Peirce speaks of chance, he is not referring to an ignorance of causes such that we call an unexplained event chance. He is referring to true chance, where things happen randomly, unattributable to any cause, not because we are ignorant of the cause, but because there is no cause, unless we permit that chance is the cause. Tyhcism flies in the face of the conventional scientific worldview of necessitarianism, otherwise known as determinism. This determinism comes from the idea of materialism, which seemingly finds support in science, where all that exists is matter. There are no immaterial objects simply because only the material exists. Since all is matter, all object must obey the law of cause and effect, with all present effects explainable by past causes and all future effects explainable by present ones, in accordance to a rule of logic, the principle of sufficient reason. However, let us consider my thought experiment. It may seem that a rock on Earth must fall when dropped from a height, obeying the law of gravity. However, consider that in the past, there was a time when whether objects rose or fell was still undecided. Some rise, some fall, the direction which it did so coming purely from chance. All the rising objects will after some time have floated into space, leaving us with only objects that fall, which is why we only see falling objects today. If that thought experiment seems far-fetched, consider what scientists tell us about matter and antimatter today. No antimatter is found naturally so far in the universe. However, experiments in particle accelerators have discovered them. In the early universe, according to Paul Dirac, there should have been equal amounts of matter and antimatter, after which they annihilate each other to produce energy. Yet that is not observed today, since we observe matter in the form of material objects and not a universe empty of matter and with only energy. One explanation goes, most of the particles created in the early universe were indeed annihilated by antiparticles, while 1 in a billion particles had no matching antiparticle and so survived to form the matter observed today in stars and galaxies. Just purely from chance it seems, we ended up with matter and only matter instead of antimatter. Rather, whichever way the coin fell, we would have named that remaining substance matter. Hence, chance can lead to strict laws, the laws in my examples being objects must fall when dropped from height and matter exists, arising from what was not so certain a long time ago, in fact close to the beginning of the universe for the matter-antimatter example. Determinists also claim that all present occurrences are caused by prior causes. One common formulation of this claim is the principle of sufficient reason, made prominent by Gottfried Wilhelm Leibniz in the 17th century, though the idea has been around since antiquity. Everything has a reason or a cause according to the principle. How things are today can in theory be traced back to prior causes and those to the causes before that, and so on till the beginning of time. The determinists concede that since there was nothing before the beginning of time, then whatever initial conditions found then determined all that came after, precisely and necessarily. What caused the initial conditions to be the way they are then? The determinists may have to concede that the initial positions and velocities of the particles at the point of the Big Bang were random. Yet, after that instant of the beginning, all was determined. Chance no longer had any further role to play. Even the outcome of a coin toss, a seemingly random event, could be predicted accurately if only there was a being intelligent enough to handle all the data and computations, what has become known as Pierre-Simon Laplace's demon. Peirce rejects this notion. He questions why should all the arbitrary specifications of the universe be introduced in one dose in the beginning, and then stop completely with chance ceasing. He thinks that the role that chance plays is not only continual, but still present today and for all time. Free will can only subsist if given an opening by chance. A mechanical universe could not deliver the variety of things that exist in the universe. Peirce deduces that such variety can only come about if chance had a role, since from the homogeneous outcomes produced by strict law could not come heterogeneity. Peirce believes that growth, life, diversity, and complexity are proof of the role of chance. In addition, mechanical laws are unable to explain the leaps found in emergent phenomena. Higher order phenomena is not reducible to lower order ones the way a mechanical logic seems to suggest is possible. Besides, the doctrine of the principle of sufficient reason implies that all laws can be explained, and not the explanation as Karl Hampel's covering law would have it, where phenomena is considered explained when its behavior is tracked back to a general law. The general laws, which are the laws of nature, remain unexplained, needing us to accept them as brute facts when the regularity is seemingly governs is what requires explanation. In a coin toss, if it kept coming up heads regularly, that is what demands explanation as opposed to if it came up randomly. In addition, we have seen that not everything seems to have an explanation. The principle is also self-contradictory, since what will explain why everything has a reason besides itself, which then makes it a circular argument. The principle can be saved, however, by allowing chance and evolution to be the broad sufficient reasons that lead us to the laws of nature. By evolution, Peirce is not referring only to the way the word is used today to refer primarily to biological evolution. He means development across all things, including ideas and knowledge. Nonetheless, evolution in biology refers to how simpler living things develop to become more complex ones. Likewise, in logic, simpler propositions are developed to form more complex propositions. That is why Peirce considers evolution as the postulate of logic. Before discussing further Peirce's view on evolution, we need to understand the second of his key principles of metaphysics, continuity or synechism. Synechism is expressed by how ideas affect one another in a continuity. Peirce proposes a law of mind. Ideas spread affecting other ideas. As it spreads, it weakens while it strings along other ideas which together become generalized, forming a new general idea. According to Peirce, ideas can only affect other ideas. Such a notion goes back to the mind-body problem of René Descartes. Descartes believes there is a dualism where there are extended bodies and unextended minds. However, one challenge confronting dualism is how material bodies can communicate with immaterial minds, since the immaterial seems to have no way to affect what is material and vice versa, given that they are completely different substances. Peirce's solution is idealism, where everything, including inanimate objects, atoms, molecules, and cells, have mind. He has already rejected determinism, which comes from materialism, and now does so again. He believes matter is merely effete mind, that non-living things possess a weak but nonetheless existent mind. While he does not deny the existence of material objects the way an extreme idealist like George Berkeley does, he believes that mind is primary and is what gives rise to matter, a view quite contrary to the common notion that matter must first exist and then become sufficiently complicated to develop consciousness. He thinks that the doctrine of materialism, where everything is only matter, fails because it is unable to explain feelings, or in today's parlance, qualia. Instead, it makes of it a mystery of epiphenomena, something not needed at all but somehow there. He views anything which has ideas as a sign of its possessing consciousness, a symptom of its mentality. Since he sees all things as having mind and hence as having ideas, things can hence communicate and interact with one another since they are really ideas, which means the law of mind applies. Ideas are for Peirce living feeling, which are inclinations. They incline us towards a particular course of action, but just because that is so, it does not make the inclined action necessary, since necessity will leave no room for new habits and ideas to develop. A person may have ideas which incline her to act in a particular way but not necessitate her to do so. In that way, our characters develop. For instance, we may feel angry with someone and our ideas or inclinations may be to hurt him, but this does not mean we have to obey our inclinations. We may instead choose to forgive, which then forms our character to be, in this example, a forgiving rather than a vengeful person. Peirce is conscious of how he needs to not only discourse over his ideas, but to prove them. He suggests that solidarity and esprit de corps in communities such as religious bodies, countries, and groups of people are proof that people, which he considers as merely ideas, can affect one another to become a collective or general idea. Peirce considers evolution as the process by which development takes place. His metaphysics is a process philosophy, where change over time is more fundamental than substance in its unchanging essence. He rejects materialism, as his worldview is that processes are the building blocks of reality rather than substances, which are just another idea, another mind. Ideas are not material objects, but events taking place in one's mind. Mind is not reducible to matter, for instance a brain, since matter in the materialist doctrine does not have immaterial feelings. He is advocating an evolutionary philosophy centered on the principle of growth. To spell out what such an evolutionary philosophy entails, he borrows from biological evolution. He sees three broad modes of evolution. Tyhcism as chance variation exemplified by Charles Darwin's theory, synechism, which is necessary progress towards a telos, exemplified by Clarence King's theory, and agapism, which is adaptation from striving and effort, exemplified by Jean-Baptiste Lamarck's theory. Chronologically, Lamarck preceded Darwin, which preceded King. Lamarck postulates that striving and exercise, or the lack thereof, cause individuals to develop adaptations in their lifetimes that are then transmitted to their offspring. These new adaptations are first developed and then brought into harmony through habit with the body. Peirce sees this as the action of love, as the name agapism from the Greek agape suggests, where perfect love needs imperfection so that it could improve the imperfect beloved and bring it into harmony with itself. This is not born of necessity but of striving, which is mental and hence not subject to the mechanism of determinism. Note that when talking about the modes of evolution, Peirce uses the suffix asm or asm, while when referring to the principles of chance and continuity, the suffix is ism or ism. Ananchasm attributes evolution to necessity. It presupposes a telos, a predefined goal which things head towards. King postulates that evolution is a reaction to crisis, such as a climate cataclysm, where out of necessity, adaptations develop in individuals to help them survive. Other anancastic theories are those that proceed mechanically, such as offspring inheriting half of their genes from the father and half from the mother. Tyhcism, such as Darwin's theory, postulates neither a mechanical deterministic inheritance nor one from striving. Instead, simply by chance, some adaptations develop which improves fitness, which then enhances the ability to survive and reproduce, or decreases fitness, which then causes the individual to perish. While recognized that the demarcation between the three modes is not sharp, Peirce proposes some tests to see which mode is taking place. Tyhcism, being chance-driven, proceeds by small steps in random directions. Ananchasm, being goal-driven, will have large steps after external crisis. Agapism is neither chance nor goal-driven, but takes place by an immediate attraction for the idea itself. Agapism ties in with Peirce's law of mind, where ideas spread and connect with other ideas. He proposes three ways where agapism's power of sympathy, that is, by virtue of the continuity of mind, takes place. The first is when the idea first affects a group of people whom an individual is a part of, after which it then spreads from them to the individual. For instance, a baby is born into a community of socialists. She obviously has no socialist ideals at the start, but is brought up to learn socialist ideals. The second is when the idea dawns on the person directly, but he only appreciates the attractiveness of the idea because of his context. Say that same baby was born not to a socialist family but a capitalist one. At first, she was not exposed at all to the neighbors, but only to her family's capitalist ethos. However, when she began school in that community, she learned more about socialism from her classmates and recognized the attractiveness of the socialist idea. In these first two ways, the individual has a sympathetic connection with those around her. The third is when the idea dawns on the individual directly by virtue of an attraction it exercises upon his mind even before he has comprehended it. Peirce calls the third way the divination of genius, where the sympathetic connection is between him and God or the universal consciousness. He raises a series of examples showing each mode of evolution in action. The key takeaway from this is not to answer which mode is dominant, but rather that development can take place from chance, necessity, and love. I think this is in line with our regular experience. Sometimes things happen by chance when, for instance, one wins the lottery. Things also happen by necessity, when an object drops from a height and by necessity falls. Things also happen by sympathy with others and their ideas, which Peirce calls love. For instance, when one is influenced by another person's philosophical belief. In each, the impact on a person's development can be life-changing, not only changing one's life, but also the lives of one's offspring. Say the lottery win allows the winner to start a business which succeeds and becomes an empire from which the winner's offspring also benefits. The object falling strikes a passerby below and that person is killed, which puts an end to that person's lineage permanently. The individual influenced by someone else's philosophical belief may teach it to his children. The reason I talk about how it affects one offspring is because I want to show the closeness of Peirce's idea of evolution to biological inheritance. Of course, it need not be just an individual's children, but also their community in each case. The lottery winner's business benefits a community. The death of the passerby becomes a rallying call against killer litter. The individual spreads his newfound philosophical belief to his friends, the way Peirce is trying to influence other minds through his metaphysical ideas. In conclusion, chance and continuity ties in well with evolutionary processual development. Chance in itself is reflected in tyhcism. Chance leading to law gives us anarchism, and continuity of mind gives us agapeism. The notions of chance and continuity are important to ground process metaphysics. Chance enables us to explain emergence and permits the possibility of free will, while continuity of mind allows us to understand how ideas can spread. Chance and continuity, together with evolution, are the architecture of theory development of Peirce's metaphysics. If his metaphysics is right, from these three concepts, we should be able to answer all the questions of the nature of reality. Thank you for listening to the Philosophical Bachelor.